Hey guys, welcome to LeetCode. Let me introduce myself a little bit. I'm Z, short for Zihan, Zihan in Mandarin Chinese. I'm a software engineer at Facebook. I live in the Bay Area. That's probably all I want you to know about me for now. So, this is the first episode of a series of videos that do LeetCode problems. For people who doesn't know about LeetCode, it is a platform with hundreds of technical questions. If you plan to interview with companies like Facebook, Google, or Apple someday, LeetCode is the place to prep you. So in this series, I'll be solving the most common LeetCode problems. Okay, enough about the intro, let's get started. Who knows what's the most famous LeetCode problems in history? I'm asking you, one of the 10 viewers who watch this video. Well, just kidding. Of course, it's two-sum. It's in the title. Two-sum is famous for being the very first algorithm problem in LeetCode, and it's also very classic and common. So the problem is, given an array of integers, return indices of the two numbers such that they add up to a specific target. For example, if we have an array of integer 2, 7, 11, 15, and a target number 9, because 2 plus 7 equals 9, so we want to return the indices of 2 and 7, which are 0 and 1. Okay, let's solve this problem together. When you try to solve a problem, you don't have to come up with the most optimal solution at first. It is reasonable to start with brute force. Brute force is the most straightforward way to solve a problem. Think about brute force first, and then optimize it. Well, what's the brute force solution here? What's the most straightforward way here? So, maybe our test case 2, 7, 11, 15 is not a good one. It's not random enough, no. I think it's time for a better test case. Good test cases are parts of the good solutions. With a good test case, you can get to the solution faster. Let's try another test case. Instead of 2, 7, 11, 15, we can do 11, 15, 2, 7. The target number is still 9. So what's the brute force solution for it? For me, I would go through each pair of numbers in this array and find the first pair that add up to the target number 9. So start with 11. 11 plus 15, now 9. 11 plus 2, now 9. 11 plus 7, now 9. And then new round. Start with 15. 15, 2, not 9. 15, 7, not 9. Okay, another round. Start with 2. 2 plus 7. Okay, we found 9. And now return indices of 2 and 7, which are 2 and 3. So what do you think about the solution? Very straightforward, but is it good enough? How do we decide whether an algorithm is good enough? Always keep the time and space complexity in mind. For people who don't know about big O time complexity, I encourage you to pause the video and check the big O video linked below. Time complexity is extremely important for an algorithm design, and it is extremely important for a coding interview. Well, back to our brute force solution. What's the time complexity of this solution? If the length of this array is n, we have n numbers, and for each number, we add it with the other n minus 1 numbers in this array. So the actual times of calculation is actually n multiplied by n minus 1, and then divided by 2. So the big O time complexity here is O(n) squared. Remember, we only care about the highest order of magnitude because when n is very big, that's all that matters. Now that we know the brute force solution is not optimal, how can we optimize it? I'm asking you to take a look at this problem and think, theoretically, what's the lowest time complexity possible? Because that's typically our goal when it comes to optimizing an algorithm. You can pause the video and think for a minute. Okay, the lowest time complexity for this problem is O(n), because in order to get all possible pairs of numbers, we have to go through each of the number at least once. So keep the O(n) goal in mind. What can help us to achieve this goal? A tip for solving problem: never memorize solutions. Think about what is your goal and what data structure or algorithm can help you to achieve that. So in this case, we want to lower our type complexity to O(n), but we have to go through every single element in the array. So which takes O(n) time already. So if every time we run into an element, every time we run into a number, we can know whether it is part of the result in one time. That would make the eventual time complexity stay O(n). For example, we have to go through 11, 15 to 7, but if when we go to 7, we could know that, oh, there was a 2 before and they add up to 9. That would be great. Is there any data structure that can help us to achieve the goal? You bet there is. It's called hash table. If you're not familiar with hash table, check the hash table video linked below. But for now, you can just think it as a dictionary, a key value pair. We can ask for any value by giving the key, and the looking up time only takes O(1) time. Enough context, let's go back to the final solution. For array of integer 11, 15 to 7 and the target number 9, we create a hash table for it. The keys are the integers and the values are their indices. So we start with number of indices of index 0, which is 11. So the hash table is empty at this time. So we just add 11 and its index 0 to the table. And then we go to number 15. Target number 9 minus 15 is minus 6. And minus 6 does not exist in this table, which means 15 cannot be added up with another number in this table to get the target number. So like the last round, we add 15 and its index to the hash table. And then we go to number 2. Target number 9 minus 2 is 7. Notice that even though 7 is in this array, but it hasn't been put into the hash table. So technically, we don't know its existence for now. So 9 minus 2 does not exist in the table. Like last round, we just add 2 and its index to the hash table. And then finally, we got to 7. Target number 9 minus 7 is 2. Great, there is a 2 in the hash table, which means 7 can be added up with the target number. We find the result. Now it's time to return the result. We can easily get the indexes of 2 by looking it up in a hash table. The result for the solution will be indices of 2 and 7, which are 2 and 3. Congratulations! We finally resolved the problem. Let's not forget the time and the space complexity of our solution. As we discussed before, the time complexity is O(n) and the space complexity is also O(n). For that we need a size n hash table to store the numbers, so the space complexity is O(n). But if you remember the complexities from our brute force solution before, time complexity is O(n) squared, but the space complexity is actually O(1), lower than our optimal solution. This situation is actually very common in computer science. Sometimes we sacrifice space to buy some time performance, vice versa. Which solution is exactly the best one actually depends on the situation. Is time or space more valuable to us? For most of the time, we care time more than space. At least when it comes to coding interviews, we typically care more about time complexity. But for real-world problem, it's really up to the context. Okay, last but not least, code. If you're wondering why this is a coding series, but I spend most of the time on non-coding things, well, the non-coding thing, the process of problem solving, is actually what really matters to technical interviews and to real-world problems. Never start to write code before you've solved the problem in mind. However, code completion does take an important part for technical interviews, at least for Facebook. It's pretty important. I'll be coding our hash table solution in Java. For interviewers, programming language does not matter, but you have to really know the language, the syntax, the data structures, the functions you use. You have to know the time complexity, the limits of them. Okay, let's start on our toSum method in Java. First, we want to initialize a size2 array of integer as the result. And then initialize the hash table. In Java, the actual hash table library is actually very old. So when we want to use the hash table data structure, we use hash map instead. After the initialization, we need a for loop that iterates every element in the array. The logic for each element is, if the map, the hash table, does not contain target number minus the current number, it means we haven't run into the result. So just add a current number and its index into the map and keep looping. But in the map, in the hash table does contain target number minus the current number. It means we've run into the result. So we want to return the indices of the two numbers and end this loop. And at last, don't forget to return your result. Well, that will be all about the famous LeetCode problem toSum. I hope you have a pretty good sense after this video for how to resolve algorithm problems. If not, maybe try to watch it again and code it by your own. And don't forget the takeaways from this problem. Remember, coding problems are never about memorizing the code. It's always about how you come up with the solution and implement it with code. Thanks for watching. If you liked my video, please subscribe, like, and comment. This is LeetCode. I'll see you the next time.